Okay.
All right, you're good.
Okay, so guys, these are our drawings and they're right down here and you can look at them and just pass it around. Make sure you don't rip your notebook, please. Okay.
Rip.
Today we're going to explain the physics of a slide to you, but first we need to give you the measurements. The reason you need the measurements is because you need to figure out how long it is and how fast you go, how high it is, and stuff like that. The distance traveled on the slide, so when you start from the top and go all the way down to the bottom, is 13 feet and 5 inches. The whole height of the slide from the bottom to the top is 58 feet and 3/8 inches. From the bottommost part, so like right here, down to the ground is 25 inches. And also something that you'll need to remember for later is that, so like from right here when you stop on the slide and when you start up there, like the flat parts, they're 3 inches different, and we'll talk about that in a minute.
A slide is a simple machine called an inclined plane. Objects are known to accelerate down inclined planes because of an unbalanced force. Force is when you push someone with your hand and they move in a
Like
direction. That is force.
When someone sits at the top of a slide, gravity is the constant force that pulls the person directly downward. Without the force of gravity pulling a person, a slide wouldn't work at all. Gravity is a core physics concept that affects nearly everything, including playground equipment.
Friction works against gravity to slow a person's descent on a slide. Friction is a force that occurs whenever two objects rub against each other, such as a slide and a person's backside. Without friction, a slide would accelerate the rider too quickly, resulting in possible injury. Also, this is where the 3-degree difference comes in, because the bottom of the slide is slightly higher than the top of the slide is. So when you get down to the bottom of the slide, it causes friction, and so you slow down and it stops you.
The object or the person is at rest at the top of the slide. The object or person stays at rest until he is pushed either by himself or someone else. After the push, he accelerates until he reaches a maximum velocity and stays in motion until he is stopped by another force. This is inertia. So when someone is at the top of the slide and someone pushes them, they go. Then as they are going, they hit a high speed and stays there until friction stops them.
When a person sits at the top of the slide, he contains potential energy. Potential energy is energy stored and exists in any object or of being capable of falling or moving. As he begins to slide, the potential energy is converted to kinetic energy. Any object that is in motion contains kinetic energy. The amount of kinetic energy depends on the mass and speed. So the kinetic energy of a person sliding down a slide depends on how much a person weighs and how fast the person is going, which are interrelated factors. No matter which way a person is traveling down a slide and no matter which angle, that person contains kinetic energy.
Are there any questions or comments?
Sixth graders? Questions? I have a question.
Yes?
You said that there are, that it depends on the size of the person. Who goes faster? The bigger one
Smaller
or the
person.
smaller?
Smaller people do.
Why?
Nikki explained that one pretty good the other day. Yeah, but you're out here. Landon doesn't really fit down the slide very well, and we have like a couple videos with her on my phone, and he like goes really, really slow because his legs are too long and he's too bulky to go down the slide really fast. And so like a smaller, like we were out here the other day watching like little kids come down the slide, and they could go really fast because they're just smaller and it works better for them.
So I want to modify that question. And I want to take this little person right here and another person exactly the same size that weighs 100 pounds more. That's exactly the same size. Which one of them goes down faster?
Without the legs, without the length of the legs.
Right.
We're just worried
the
about
one that weighs more. Does.
Yeah.
If we put a jacket on her that weighed 100 pounds,
She'd get on.
but the jacket didn't touch the slide, so now she weighs 175 pounds and she weighs 75 pounds, do they go down the slide at the same speed?
No.
Which one goes faster?
The heavier person.
The heavier one goes faster because of?
Gravity tends to pull bigger things down faster.
Oh, okay. Very good. Anything else, guys?
So how does a slide work, 6th grade?
Can you tell me what simple machine a slide is?
They told us.
Because I'm pretty sure the 6th grade standards has simple machines in it.
Just take a wild guess.
Yeah.
Incline plane. Actually, this slide is technically 2 combined into 1 because it's a screw and an incline plane slide
Because the screw is
wrapped around.
what wrapped around?
What's it called?
What is this?
What gets wrapped around?
An incline plane gets wrapped around a spherical object.
There you go. An incline plane gets wrapped around the center shaft, which is probably a metal pole, right?
Is it metal pole or is it all plastic?
It's metal inside that.
Well, if you get down here and look,
Oh yeah, it is.
there's a metal pole, right?
Thank you.
Upperclassmen, do we have questions for these guys? Did they leave anything out? Is there anything that you question whether they actually covered it?
We have videos.
You have videos, but you can't show them out here?
I can. I have my
And
phone.
we're out here because,
We didn't need the video because
Yeah,
I
because
did it.
it's Landon sliding down.
Okay.
Because like he was,
Back.
or it says on site.
Boom.
they did the on-site, they did the live demo instead of a video.
Yeah.
And they have the videos which they can turn in to technically meet the requirement.
Yeah.
So we're good.